Good day, sir. My name is Montgomery Van Bursel A. Toft, a student from BSCP 41. I've been your student also last sem for computer architecture, and today I will discuss about embedded systems. So, upon doing my research, I have discovered that embedded systems are specialized computer systems that do a specific function for a device for a specific type of hardware. So, as you know, we have general type computers which can do anything. They can compute, they can access the internet, they can you can do many stuff with them. You can play games on them. But sometimes, for example, in a simple sari-sari store, when you need to do some quick calculations with groceries, or when someone buys many stuff, um, it's like overkill, or it's overkill to use a laptop just to do a simple calculation. So we have what we call calculators. So calculators, their sole purpose is to just compute. So as you know, calculators are one example of embedded system. So embedded systems, in short, are types of systems that serves a special purpose only, like for example the calculator and many other ones. Some types of embedded systems are like the embedded subsystems, which are part of larger systems, but subsystems, they have a specific task to do for the entire or the main system. Networked embedded systems, they are the what we call the Internet of Things. So they serve a specific purpose in a wide network which is connected to a wide network. And also we have yeah, like the calculators, the specific other types of embedded systems. So as you can see, embedded systems were developed to serve specific purposes. Now, for further innovation in embedded systems, computer engineers or software engineers throughout the years, now I can see that we are focused more on networked embedded systems, which is the Internet of Things. So I can see today that the goal of most engineers is to make everything connected to the internet and make everything in our home interconnected to each other. I watched I watched a series before which is called Future Home of the Future, and I saw there it's a house, but every appliance, the oven, the lights, which we can see today eventually, the even the door, they all are connected in one system. So for the door, for example, you use biometrics already to open the door or close the door. So it will only open when you put your fingerprint on it and it identifies you. So it has a database. For the lights, I saw that it's voice commanded. So when it hears a voice command, it will do its specific task. So what I saw is today, the innovation that we computer engineers need to do is make embedded systems more like uh, accessible to people and push its boundaries by push its boundaries by making it more convenient to use, and also bringing new technology like that, like the biometrics and the Internet of Things, the wireless fidelity. We use other methods to make embedded systems more innovative for people. um so examples is, yeah, the house. Another is in the car. So in the home of the future, I see a car. It has a self parking system, which the self parking system, what it did is you just click a button, then you can basically not drive, and the car will park itself on the parking. So that's one example of embedded systems in autonomous vehicles. In the military, I cannot The military, I can see now that they have like digital training programs that like you can use VR and then can simulate like a battle environment for soldiers. So that's an example of embedded system. In education, there are already many. So for education, we already have embedded systems for like 3D presentations, like in space. Like for example, when I went to Taguig, it's called planetarium. It's like a planetarium, and then yeah, it's like a 3D space dome where we learn stuff. So that's an example of a embedded system. And in healthcare, there's many embedded systems healthcare, like yeah, the monitoring systems for patients is an embedded system in hospitals which tells its heart rate, his blood, like sure, uh also the device to tell if heart rate and oxygen rate, like that, the one in you can see on most hospitals. That's an example of an embedded system. So yeah, those are the different applications on different fields of an embedded system. So I think embedded systems, there is a lot to pursue in embedded systems, since first of all, embedded systems of course need experienced programmers to do a specific program for it. Seems since that's one of the challenges or cons of an embedded system, because they are hard to code, because yeah, you need to code or program them for a specific hardware. So your code need to be optimized. You need to optimize your code to run in a specific hardware. So most of our code we can run it on computer, but we cannot do it like we think that when it runs in our computer it will run on any device. That's not like that. So for embedded systems, you need to optimize your code so it can run on that system. So like in calculators, I bet that the programming calculator is a simple machine device, but I think the code or the programming did for the calculator is very complex, because even what we call the scientific calculators now, because they have more specific functions that you can do. So I think in embedded systems, the careers you can pursue is like bigger if you're a seasoned programmer, or you're experienced on hardware specifications, like complex hardware specifications. Also, um, I think that that a career in embedded systems can be fruitful, because as we know, we are entering the future where the digital era is vast or big, and also people rely more on technology, which most of the technology is reliant on embedded systems. So I think uh, there's a big there's a big um, opportunity for us to have a career pursuing embedded system development. So yeah, so since since embedded systems can be a possible career for me, I'm keen to pursue it, but I am more on web development or development of websites, because currently I am doing front end code as a sideline job. And what I do mostly is UI UX stuff, so interface stuff. So I'm not involved much on the process stuff. Although there are some times where I need to calculate something or do some stuff that like interaction of between user input, and then to the what should happen on on the website itself. So but if I think it's good to pursue, for me, I'm willing to learn what language needs to be used in embedded systems, or um yeah, the language or the stack needed to pursue embedded systems. So if I wanted to pursue a career on embedded system, I think I will mostly go on the network embedded systems. That will be the thing that I will be most curious about, because I'm curious about, yeah, the Internet of Things. I like to try to, like, yeah, connect my light to, because I can see it. It's cool. I'm curious to know about how to make a light voice activated like that, or maybe, yeah, even a simple fan in your room. I want to see that it's voice activated. So I think if I were going to pursue an career in embedded system, I will mostly go on networked embedded systems or the Internet of Things.